everybody. My name is Nilou. If you don't know me, please come up and introduce yourselves to me because I would love to know you, but I think I know everybody else because I'm a sixth year. My advisors are Matt Herkin, Andy Jacobson, and Maggie Osborne, and I'm going to be giving a brief little preview of my dissertation talk, which will hopefully be happening in like winter quarter. But yeah, so I study the Neoproterozoic, and I specifically study negative carbon isotope excursions in the Neoproterozoic. And just like a brief background, the Neoproterozoic is like from 1 billion years ago to like 542 million years ago. It's like a long time ago, and it's really weird for several reasons. But I'll just talk about this reason here. It has the largest negative isotope excursions like found in the rock record. Specifically, this is the largest negative isotope excursion found in the rock record. And for reference, like the Phanerozoic, like it's like plus or minus 1 would be like a ginormous excursion. The fact that we're getting negative 12 is like crazy, and people don't really understand why. And and so I look at these negative carbon isotope excursions and maybe like their connection to climate. And I'll talk more about how I do that. But I have 3 chapters in my dissertation. The first one is looking at the Isla excursion at this one location in the Northwest Territories of Canada using limestones. And then my second chapter will be talking about the Sharam excursion, which is the largest negative isotope excursion in Earth's history, or in the rock record. And these samples are from Oman. And then my third chapter is something I'm really excited about because it's the same excursion, the same location nearly, separated by several kilometers, same formation, but dolostones. And so looking at how the mineralogy changes sort of affect what we understand about these excursions is something that I'm really excited to explore. The way that I'm doing that is using our novel multi-proxy, is what we coined, right, Andy? I look at strontium isotopes and calcium isotopes in carbonate rocks of different mineralogies. And we found that it can sort of give us indication of different, it's helpful for us to understand kind of a couple different things: precipitation rate, maybe fractionation factor changes, maybe fluid composition changes, and potentially even PCO2, since there's a relationship between PCO2 and, oh God, carbonate precipitation. Okay, so I'm just going to zoom forward and talk about, this is just a preview of my dissertation. We'll talk more about that later, okay? I want to talk to you guys about what I've been up to. So many of you guys have been like, I want to show you guys what I've been up to, and specifically thank my advisors for funding me to do really, really dope stuff. I went to the ARPA-E conference in March. ARPA-E is Advanced Research Projects Energy, or Advanced Research Projects Agency Energy. It's like a DOE affiliate. If you care a lot about climate change and trying to do something about climate change, ARPA-E conference is a great conference. Incorporates venture people, government agencies, NGOs, like all these people come together. I then went to Hawaii and presented my Sharam project at Goldschmidt. That was super dope, super fun. That made a ton of friends, learned a lot about science. And most recently, I just got back from Lima, Peru, because I went to the 5th International Symposium on the Ocean and the High CO2 World. Okay, long name, but really great conference. I believe that paleoceanographers and modern oceanographers should have more of an overlap, and I thought this was a really great conference. In the future, I just got accepted to go as a Northwestern delegate to the UN Climate Conference, COP27, which is going to be in Egypt. I'm really stoked. I think that if you're a paleoclimatologist, you should apply and keep an eye out for this stuff, because they send law students and Kellogg students, and they need to be talking to us, the paleoclimatologists and the climate scientists. And then in March, I will be moving to Paris to try to start my own climate tech company, talking about marine carbon dioxide removal. I have another slide explaining what that is, but if you're interested, come talk to me afterwards. Thanks. Any questions? Yes.
So the dolostone that you're planning or comparing with the limestone, is it interpreted to be a primary depositional dolostone or a secondary alteration?
Hit the nail on the head. That's going to be a huge part of my dissertation. A lot of people think that Neoproterozoic dolostones are a product of diagenesis, that fluid flowed over it and remineralized a lot of those compositions, but our proxy can try to help deconvolve that signal. And so that's why I'm so excited to find out, because there are other people who think there's primarily precipitated dolostone in the Neoproterozoic. because the kinetics of that time period were so different from what we have now. Like you can't, there's a whole Dolostone problem. It's a big problem. I won't get into it. I've been talking too much. But does that answer your question? Okay, great.